Today, video will discuss lesson 3.1, which talks about some of the relationships between lines and planes that we will have throughout the geometry class this year. These are some big, very important geometry terms, the first two especially. When we talk about parallel lines, now, if you need to, you can pause this video, get all these definitions and drawings down, because to me a picture is worth 1,000 words. And again, in the pictures we have some symbolism and some notation that we can use while writing these to save us some time. So let's talk about parallel lines. Parallel lines are lines that lie in the same plane and never intersect. Okay, so to imagine this, we have to be in the same plane. So on the same sheet of paper, if we draw two lines and we draw them the same distance apart, meaning if I measure from here to here and that's 4 inches, and I come out here and I measure from here to here, that's also got to be 4 inches. Now that's how, in the real world, that's how we would get parallel lines. We'd draw one line and then we would measure away from that 4 inches, and then we'd go down further down the line, measure 4 inches, and you could connect those 2 points, and that would give you two parallel lines. So they're lines that lie in the same plane and never intersect. Now we have some symbolism here within the drawing that, let's say I don't want to make you measure and say, all right, measure here to see how if they're the same distance apart. If I want to say these two lines are parallel in a drawing, I can put these little arrowheads in there. If I had another pair of parallel lines over here and I wanted to show that these two guys were parallel, I would put an extra pair in there to differentiate between, hey, these two are parallel and these two are parallel. So those little arrowheads on there mean, hey, these two lines are parallel. Now here's another symbol that we would use. If this is line A and this is line B and I want to make a statement that they are parallel, I can say line A double backslash parallel to B. So this symbol right here, the double backslash, is what we would use to show those lines are parallel. Now we've previously discussed that just a little bit in a prior class. Right. Now here we go. Here's a big geometry term, perpendicular. Perpendicular lines are lines that intersect at a 90-degree angle. 90 degrees are so very important. If you're talking about engineering, architecture, construction, you always need right angles. If you look around a room, you're going to see an endless amount of right angles. Right. So if we have two lines that are perpendicular, to show that in a drawing, this would be a 90-degree angle right here. To show that in a drawing, we put that little box, and we've seen that before. That means, hey, this angle right here is 90 degrees. Now if you start thinking, that means this guy over here, vertical angles, this guy's got to be 90 degrees, and then both of these guys would be as well. Alright, so that's how we would show it in a drawing, is that little box in the corner. Now, to make a statement like this, that x is perpendicular to y, here's our little symbol for perpendicular. It's an upside down capital T. This is literally read, x is perpendicular to y. So that upside down T is just a shorthand for saying perpendicular, because I'm pretty sure you don't want to write out perpendicular all the time. Alright. Now, skew lines are going to be the confusing one. Skew are very similar to what we would call parallel. But the definition of skew lines, again, you can pause this and get these definitions written down, are lines that do not lie in the same plane. Emphasize the do not, because up here parallel lines they were lying in the same plane. But here these guys do not lie in the same plane and do not intersect. So similar to parallel in the fact that they don't intersect, but they don't lie in the same plane. All right, now to think of this three-dimensionally, if you think in my room I have a chalkboard on the front wall, I have a chalkboard on the back wall. If I draw a line on the front board and a line on the back board, those two guys are not parallel because they don't lie in the same plane. Those two would be skew. So here's my front chalkboard, here's my back chalkboard. These guys will never intersect because there's space between them, and they do not lie in the same plane, so we would call those guys skew lines. Now there's no short, sweet symbol for skew, just use the word skew. Alright, parallel planes, nice easy one. Those are planes that never intersect. Easy way to think of this would be walls in a room. The floor, the ceiling are parallel. Left-right walls would be parallel, and the front-back walls would be parallel too, as long as they did their construction right. Alright. Let's go down to the next one. Perpendicular planes, again, another very simple one here, are planes that intersect at a 90-degree angle. And you can think of this as the floor hitting the wall. Those are going to be perpendicular. Now, what I also want to review real quick is, if you remember, if I intersect two lines up here at perpendicular lines, those two guys are going to intersect at a point. Two lines intersect at a point. But if we intersect two planes, two planes are going to intersect all the way along that line. So two planes intersect along a line. Now that's a review. Alright, so planes intersect at 90 degrees perpendicular planes. Now a line perpendicular to a plane, what's going to happen here is if we have our little plane, you can imagine shooting an arrow through a wall or maybe stabbing your pencil through your sheet of paper. It goes straight down at a 90-degree angle, hits, goes through, comes out the bottom. Now what happens here is if I'm going to draw some lines in that plane and I go through that point that line hits that plane, that line is actually going to be perpendicular to every single line that I can draw on that plane through that point where it hits. So this line A here would be perpendicular to every single line that I could draw on that plane through that point. I can draw infinitely many of them, if you remember. Let's go through a few examples. So let's look at this simple drawing over here. We just have a nice pretty plane. We have a few lines there. Let's look at name two parallel lines. Well, the parallel lines would be the two guys that lie in the same plane and don't intersect. So that would be line X, and line Y. Now, I'm not going to put my symbols on there. We're just going to assume that those are lines. Now, let's name two perpendicular lines. So what we're looking for is we're looking for a little box right here. Here we go. So my two perpendicular lines would be Z and X. Now, what you need to start doing is thinking three-dimensionally. This line Z starts above that plane, not on it. The only point that line is on that plane is right there where it hits. Comes down, goes through, goes underneath it, and then comes out the bottom. So if you look at this drawing, Z does not intersect Y. Those two do not intersect at all. So now when we go to name two skew lines, Z does not lie in the same plane as X and Y. It does intersect X, but it does not intersect Y. So my skew lines would be Z and Y. Next example. So now we have a couple more planes here to add it to this. So let's name two parallel planes. So let's name two planes that look like they don't intersect. Well, that'd be B and C, no problem. Plane B, plane C. Name two perpendicular lines. Okay, so when we look at this drawing, I see a box here, I see a box here, so we actually have two sets. We could say that L is perpendicular to M. We could also say that L is perpendicular to N. So we have two different answers here, and you only need one of them. Now let's name two skew lines. So now remember, skew are lines that are not going to lie in the same plane and don't intersect. So it can't be L and M because they intersect. It can't be L and N because they intersect. So my two skew lines are going to be M and N. Even though he's a bad rapper, he's the answer here. All right, now let's go to number 7. Let's name two planes that appear to intersect. Okay, so two planes that appear to intersect would be this guy intersects this guy, so B and D. But we could also say C and D. All right, so those are my intersecting planes. All right, next example. Now we're going to get a three-dimensional shape. Now if you could imagine, and this is called a rectangular prism, kind of like a box of cereal. We want to name two parallel planes. Now I don't have the big, bold, beautiful letters like I had right here to name this plane. So we need to think back, how many letters am I going to need to name a plane? Well, I'm going to need three of them. Three to determine a plane. So let's name this top guy, QRVU. Now I could go QRVU. That's 4. Now remember, I only need 3, so what I'm going to do is I'm just going to go QRV. That includes U. That includes that plane. So what we're looking at, what plane is parallel to that top guy? Well, the top guy is going to be parallel to the bottom guy. So if we call this QRV, the parallel guy would be TSWX. Now remember, we only need 3 of those. So I'm going to go TSW. Those two are parallel planes. Okay, now let's name some perpendicular planes, okay? I'm going to keep that top part. Now, if you can imagine your box of cereal, you have your top, but then you have 4 sides coming down all the way around them, and actually each one of those sides is going to be perpendicular to the top. So if we name that same top plane QRV, which is the top, we just need to name one of the sides that comes up to it. So I'm going to go over to this side, and I'm going to name this. Would be UVWX. Now remember, we only need 3 of them. UVW. And we could call that good. Those two planes are perpendicular. Now we need to name two parallel lines. Now this is where it becomes kind of tricky here grading these for me, because you could have all sorts of different answers here and still be right. So I'm going to name two parallel lines. I'm going to start with the one they have drawn, VW, because I like bugs. So we'll call it VW. And plus they have that line drawn, so I'm going to go ahead and use it. Now remember, any of these sides we could extend and draw a line through there. Because remember, how many points do we need to determine a line? Well, 2, and we have a bunch of pairs of points here that we could use. So we want to name that line that's parallel to that. So we could go UX, we could go QT, that's probably the prettiest one, and then RS. Now some of you are saying, well, QT doesn't lie in the same plane. U and X are on this plane with that guy. R and S are on that back plane with that guy. But QT isn't on the same plane. Well, then you got to go think back to that stupid saying I always say, just because it's not there doesn't mean it's not there. Could we draw a plane between VW and QT? Well, yeah, we need 3 points to draw a plane, and we have 4 there. We could draw that plane, actually. All right, so we could use any one of those 3. I'm going to go ahead and use UX as mine. All right, so let's name 2 perpendicular lines. I'm going to stick with VW. I'm going to stick with VW. All right, so let's use that line. Now, perpendicular, we have actually 4 lines that come and hit this line. We have this guy, we have this guy, and we can come off the other way, this guy, and this guy. So we need to name one of those 4 that intersect. Well, you're saying, Mr. Dreyer, this doesn't look like it intersects at a 90 degree. You got to remember that this is a serial box, and all of those guys intersect at right angles. So this would actually be a right angle just because it doesn't look like it. It's 3-dimensional. It is. So we say VW, and I'm going to go UV. Okay. Just don't make it a ray because that's bad for your skin. All right. Now, if we name number 12, name 2 skew lines. I'm going to stick with VW. Now, you wouldn't have to use the same line over and over again. I'm just going to make it easier. Now, skew is going to be, all right, it doesn't intersect, but it does not lie in the same plane. So UX did intersect, but that lied on that same plane. All right, so we can't do that this time. So my answers here, VW would actually be skewed to QR, or RQ. It would be skewed to TS, they never intersect. It would also be skewed to QU and TX. Okay, so we could use any 4 of those. Now you say, well, that intersects right there, but no, you got to think 3-dimensionally. There is space between those 2 guys. So the answer here would be VW and any one of those 4 points that we said. I'm going to use TX. Right? So that is lesson 2 or 3.1. Now you could do Math Excel 3.1. If you do have questions, please come see me. If you still don't get it, please come see me and I can re-explain it to you as well. Thank you and good luck on the Math Excel assignment.